Hi everyone, this is Team 13 and our project is Parkies, which is basically a project helping you to find your parking location and helping you to track where there is a parking spot available. So this is the demo video of week 2, and this part is basically an intro of our project, and here we go. So this is a parking building and you're driving a car and you want to find a parking spot in this parking building. And next, after you get into the parking building, you've noticed that all the parking spots they have already taken by other cars, but for most of the time you need to search through this floor to get to know that there isn't any available spot for parking. After all times you spent in searching a parking spot and you finally parked your car successfully, and now it's time for you to find your parking spot in that huge parking building, which basically will take our more than 20 minutes or even 30 minutes to find your car if you're not able to recall your parking location and your area code or something like that. And we try to make an app based on your parking location. This is a particular map look like, which is you give location to your car and then you can use your phone to find where your car is. But in this point, we use the parking spot as a location place. It's like we'll have a sensor to help you to detect when you have already parked there, and we also have a car plate license recognition system to help we combine the parking spot, the number of the parking spot, and your license together so that you can use this app on your phone to track where have you parked the car, and which will help to make it easier for you to find your car in such a huge parking building. These are some basic statistics of cars. So to our surprise, basically there is more than 3.3 parking spots for each car in LA. But although it is still hard to find a parking spot, but this is the statistics we've searched and looked into through the internet. And we've also noticed that average number of vehicles per household in California is 2.3 per household, which means that we have a lot of cars in LA and we also have a lot of parking spots in LA. So this project is to help you find your parking spot, find a parking spot, and help to find your car after you successfully parked your car. And this is the survey result. We have distributed a questionnaire to help us gather people's thoughts about about this system, and the questions on the left is how frequently do you encounter difficulties in finding parking spots in urban areas. We've noticed that more than 80% of the residents in LA find it sometimes more or often or always find it hard to find a parking spots in urban areas, although we have a lot of parking spots. And the question on the right is how comfortable are you with the system using license plate recognition to locate your car. So basically, except for 7.4% of our interviewers find it not valuable on this system, and more than 90% of our interviewees find it somehow find it valuable about this system.
Hi. So for the progress update of this week, we successfully set up the distance detection function. So the result is that we successfully interface the IR sensors with the central monitoring system for real-time data capture. And we also achieved the measurement of distance using IR sensors. And for the next step, we plan to calibrate the sensors for enhanced accuracy in diverse environmental conditions. We also need to set up the conduct intensive field tests in active parking scenarios. And on the upper right photo, we can see the physical setup of our IR sensor, our X dot, and our gateway. And here we are detecting the distance between the IR sensor and the box. And for the lower image here is the test code for our VL53L0X IR sensor. Basically, it just set up the sensor first and then just output the distance it detects. And then we also generate a code that can communicate with the node-RED based on the distance detected. So basically here we also first set up the sensor every loop, and then um, we will get a distance it detect, and if the distance is larger or equals than 150 millimeters, it will send a message to node-RED of occupied, and then it will just sleep for a while and then trigger the whole process again. And other image here is the node-RED of our gateway. When the gateway got a message of occupied, it will forward it to another node, which is the Raspberry Pi. And here is our node-RED for our Raspberry Pi. Basically, is that when the Raspberry Pi got a message from our gateway, it will first trigger execution of ping Google, and this execution will be replaced later to take a photo and run CV model. And for now, the output here is the reply of pinggoogle.coms, and but later it will just replace it with the return license plate detection number, and later we will forward it to the AWS for later data analysis. Thank you.
In the last week, we have already implemented the license plate recognition system. We leverage WPortNet model to detect the license plates from the vehicle images and then segment them. Our system supports many different countries' license plates, including United States, China, Japan, Thailand, and India. Um, then for the segmented license plates, we perform some image processing operations, including gray, blur, binary, and dilation. And then we use a deep learning model to recognize the characters on it. So in the next week, we're gonna implement this system on a Raspberry Pi with a camera. Also, we're gonna conduct some field tests to validate this system. Thank you.